Good day, students. I welcome you to another exciting class. Today we shall be continuing in our lecture series, Trigonometry. At the end of this lesson, you should be able to know the value of the trigonometrical ratios of special angles, as well as to solve problems involving trigonometric ratios of special angles. What are special angles? We have three major special angles in trigonometry, namely angle 30 degrees, angle 45 degrees, and angle 60 degrees. In order for us to know the formula that is used for each of these special angles, let us consider the triangle on your screen, a right angle triangle whose sides are in the ratio of 1 to ratio 3 and to ratio 2. If you look at this triangle on your screen, you have an angle of 60 degrees and 30 degrees. So let us derive an expression for the angles of 30 and 60 degrees. From that triangle, the sine of the angle is opposite all over the hypotenuse, while the cosine of the angle is adjacent all over the hypotenuse. And so the angle 30 degrees will have a value of 1 over 2, while the cosine of angle 30 degrees will have a value of root 3 over 2, and the tangent of the 30 degrees will have 1 over root 3. Similarly, if you consider the right angle triangle based on the angle of 60 degrees, the opposite will become root 3, while the hypotenuse will become root 2. And so the sine of the angle 60 degrees will be root 3 over 2, while the cosine of angle 60 degrees will be 1 over 2, and the tangent of angle 60 degrees will be root 3 over 2. Let us consider angle 45 degrees. To consider angle 45 degrees, we are going to use a right angle triangle whose sides are in the ratio 1 to 2 and to root 3. So let us look at the diagram of the right angle triangle. It is on your screen. So if we consider the right angle triangle based on the angle 45 degrees, then the sine of 45, which is opposite all over the hypotenuse, will be 1 over root 2, and the cosine of the angle will similarly be the same value, which is 1 over 2, while the tangent of 45 degrees will be 1 over 1, which is equal to 1. If we combine these tables, the values of the special angles 30, 45, and 60 degrees together, we are going to have the table that you have on your screen. And so the sine of 30 degrees is as enumerated in the table on your screen. Let us take an example involving the special angles. We have a right angle triangle on your screen, and we are told to find the length of the side marked S and Y in the diagram. To get this figure, to get these letters, I'm going to label the right angle triangle. So if you consider this triangle on your screen now, first of all, we are going to find the lettered side X. The cosine of the angle, which is 60 degrees, will be the adjacent of that triangle, which is 2, all over the hypotenuse, which is the side we are looking for, X. Of course, from the earlier table, you would observe that cos 60 degrees is 1 over 2, so that that value will be equal to 2 all over X. If you cross multiply that, you are going to have X being equal to 4. To get the other lettered side y, we have to first of all find the side h. And so we are going to use the tangent of angle 60 degrees to get the side h. Tan 60 degrees is root 3. And if you cross multiply that, you are going to have h being equal to 2 root 3. Having gotten the value of h, we are now going to find the lettered side y. And we are going to now consider the triangle based on the angle 30 degrees. The sine of that angle 30 degrees is equal to the opposite all over the hypotenuse. You would recall that we have already gotten the value of h. And so if we substitute that into the expression, we are going to have half being equal to 2 root 3 all over y. And if you cross multiply that, you are going to have finally y being equal to 4 root 3. So that's where we are going to stop for today's class. I thank you very much for listening and watching this video. I'll see you next time. Bye bye.